Hello, hello. Today I'm just going to discuss z-scores and how to read this lovely table. Before I start, let me talk about this formula that we're going to use. So this is the z-score formula. Okay? X is the value you are given. Okay? A sample. Okay? X bar is the mean. Remember that we can use a mu or we can use an X bar. They both mean mean. And then the O is standard deviation. Also, SX is sometimes used for standard deviation when we are doing data. So just a recap of symbols. Okay, now what we're going to be given is one value point, and we're going to be given a mean and a standard deviation. So that one value point is going to be put into this formula along with the mean and the standard deviation, and we're going to find something called a z-score. Now, before I use this table, know that the z-score is a number that gives you a decimal that represents everything below that sample number. Okay, so what we're going to do is we're going to calculate a z-score. Our z-score is going to be something like negative 3.2, negative 1.7, 0.5, 1.7. Okay, your z-score is going to be a number in between negative 3.9 and 3.9. Okay, so your z-score is a number in between negative 3.9 and 3.9. And then we're going to take that z-score number and convert it into a decimal, which is going to give you the percentage of everything below that number that you had. Okay, so there's just like a brief overview of what we're doing, but I think it'll make more sense once we do a problem. So the way we read this z-score table, first of all, is the number on the left would be the starting number in front of the decimal point. So if we had the point negative 3.1, we go to negative 3 on the left side, 0.1 across the top, and this would be negative 3.1. Okay, it would be right there. Okay, in green, what if we had 1.4? Okay, we go to 1 on the left side. This is my whole number. Okay, and then across the top is the decimal. So 1.4 would be right here. Okay, and this decimal represents the decimal for the percentage of all the numbers less than that z-score. Okay, it's always less. For example, the number 0.6. Okay, we would go to 0. We would go to 0.6. This would be the number 0.6. Okay, again, 0.6 going across 0.6. Last example, if we had negative 0.4, we go to the negative 0 part, and we go to negative 0.4, it would be right here. Okay, so that's how you read it. This is the whole number, or the number in front of the decimal. These are the decimals. As you can see, these are all rounded to a tenths place, so our z-score always has to be rounded to a tenths place. Okay, so that's just a little bit of detail. I'm going to write z-score round to 10th place. Okay, now here we go. It says, if you want to know the area under a normal curve for which the boundaries are not 1, 2, or 3 standard deviations away from the mean, we can use the z-score table and the formula. Remember, the answer is always for less than. We must subtract from 1 if it's greater than, and I'll explain that as we go along. So let's just start with a problem. Okay, this first problem says, let's get this all nice and neat. A light bulb company advertises that their 75-watt light bulb lasts an average of 500 hours with a standard deviation of 30 hours. Find the probability of each scenario using the formula and table above. Sketch a picture to help give you a reference. So I'm going to start by creating my picture, which is always the first step. My mean goes in the middle. My standard deviation is 30. So 530, 560, 590, 470, 440, 410. Okay? Always start with your picture. Now, if this says, what's the percentage of a light bulb that you have an average of less than 425 hours? So, this is very similar to what we did last time with our calculator, because 425 is not directly on a standard deviation number, but instead of using our calculator, we're going to use something called a z-score. So the only way we know to use a z-score in this problem is because the directions will tell you to, okay? So the way you use a z-score is you use the formula z equals x minus x bar over standard deviation, where x is your value, which in this case is 425 that you're given, okay? Your x bar is your mean, and your O is your standard deviation. Okay, so the value in this problem is 425. The mean is given to us in our original sentence. It'd be 500, and my standard deviation is 30. So to answer this first question, I'm going to plug into my calculator 425, which is my x value, minus 500, which is my mean, divided by my standard deviation, which is 30. Now, either use parentheses so that the top subtracts before you divide, or put it in your calculator separately and do the division second. I always like to put it in my calculator separately. So I would start with 425 minus 500, press enter and get an answer, and then divide that answer by 30. So this z-score is negative 2.5. Okay? For every single problem that we have, our z-score is going to be recorded, and then we're going to go back and find the probability. Okay? So the way you use this z-score, it's negative 2.5. I'm going to go to negative 2. I'm going to go to 0.5, and I'm going to trace all the way across. And my answer, my p, would be 0.0062, okay? Which I must multiply by 100 to get a percentage. So 0.0062 times 100 is 0.62%, okay? For my class, I always want you to give a percentage as your answer. For other teachers, just ask your teacher if they'd rather you give the decimal or change it into a percent. I'm not sure what every teacher will choose. So you could give 0.0062, or you can give the percentage of 0.62. So for my class, this is your probability. Okay? Now, this problem said less than. Okay, take note of that. When we do less than, that means that the answer that our table gets us is going to be the answer. If it's greater than, then we're going to have to do something else. Okay? So, in the next problem, we have what percentage of light bulbs have an average life of more than 550 hours? So, I'm going to go to write down my formula. Okay? X would be your value, which is 550. X bar is your mean, which is 500. And standard deviation is 30. Okay? So I'm going to plug it in. 550 minus 500 divided by 30. 550 minus 500 divided by 30. Okay? My z-score is 1.7 because I have to round to a tenths place. So my z-score is 1.7. You will start to notice that if your value that you're given is bigger than your mean, it's going to be a positive number. In the previous question, our value was smaller than our mean, which is why it was a negative number, okay? Now, here's the trick with this one. This problem is greater than. Because it's greater than, whatever our p-value is, we're going to have to subtract from 1. Okay? All of the values for the z-table are taking into account that it's the shaded region less than the x value that you're given. So if the x value is going to be greater than that, then you're going to have to take 1 and subtract it from the p-value that you get, okay? So always remember, if it's greater than, you take your p-value from your table and you subtract it from 1. So I'm going to go back up to my table, okay? My z-score was 1.7, so I'm going to go to 1 and I'm going to go to 0.7. We get 0.9554. Okay? Now back down to my problem. Because we get 0.9554 and this is a greater than problem, I'm going to do 1 minus 0.9554 and that is going to be my final answer, which is 0.0446 multiplied by that 100 and you get 4.46%. So 4.46% are above that x value because 95% would be below. Okay, next one. What percentage of light bulbs have an average life of more than 450 hours? Let me pause this one and write some stuff down. Okay, so the value that I'm given is 450. The mean is still 500. The standard deviation is still 30. X minus the mean divided by the standard deviation, I get negative 1.7 because I rounded. Now, this problem is greater than. Because it's greater than, I have to take my p-value from my table, and I have to do 1 minus that. So, going up to the table. My z-score was negative 1.7, so negative 1.7 is 0.0446. Okay, now I'm going to subtract that number from 1. So 1 minus 0.0446 is 0.9554, so 95.54%. Okay, now the reason that's true is because my x value is right here, and we are greater than. So because we're greater than, we have to take 1 minus the p-value from the table. Okay? The p-value from the table always gives us the less than value. Last one. What percentage of light bulbs would have more than 430 but less than 520? Okay, so this time you have to do the problem twice. You have to use an x of 520 and do the problem out, and an x of 430 and do the problem out. Find a z-score for both, and then find your p-value for both, and then I'll pick up from there. Okay, I realized that all of this stuff just popped up, so let me explain it. So I used 520, which is my higher value. 520, mean of 500, standard deviation of 30. I plugged it into my z-score, and I got 0.7. This is from the table. Okay, so my final p-value from the table is 0.7580. Okay, then I did the same thing with 430, mean of 500, standard deviation of 30. I got a z-score of negative 2.3, and this is my number from the table. Now, if you are ever given a bigger and a smaller, you're given a boundary, both low and high, you take the bigger or the higher one, and you subtract the lower boundary. So my 520 p-value minus my 430 p-value, and 0.7580 minus 0.0107 is 0.7473, which leaves me 74.73%. Okay? So you always take your higher and you subtract your lower once you get to the p-values off of the table. So 0.7580 minus 0.0107, and I get 74.73%. That is the end of this video.